So dear students, today we are going to learn a new topic, amino acids, proteins and nucleic acid. Now why this chapter is combined as such that amino acids, proteins and nucleic acids. We know that these three are related with each other. Amino acids combine together to form a proteins, and proteins are part of the nucleic acids. So what are amino acids? We will be learning this chapter step by step and build upon a completed chapter. First of all, today we are going to start basically what are amino acids. Amino acids are small molecules that are building blocks of proteins and are compounds that play many critical roles in our body. They are needed for vital processes like building of proteins and synthesis of hormones and neurotransmitters. Proteins serve as structural support inside the cell and they perform many vital chemical reactions. Each protein is a molecule made up of different combinations of 20 types of smaller or simpler amino acids. A peptide is something that two or more amino acids, when they are combined together, they form a bond called a peptide bond. And a polypeptide bond, like that amino acids are combining together to form a peptide bond, and the polypeptide bond is called proteins. Therefore, proteins are actually long chains of amino acids that are held together by peptide bonds. So, that's why this chapter is a combination of amino acids, which are the building blocks of proteins, and proteins again in turn are main part of a nucleic acids. So first we are going in detailed study of amino acids. What are these amino acids? Amino acids, the name itself says that amino acids are the combination of, amino acids are actually the combination of both the amine and acid. Amine and acid. That's why they are called amino acid. So from where they are obtained? Actually they are derivatives of carboxylic acid. Carboxylic acid means carboxylic acid, all of us know that in our organic practicals we have done then, so carboxylic acid. Okay, so the basic general formula of carboxylic acid or the functional group of a carboxylic acid is C double bond O OH, and there is a group R which can be either alkyl group or allyl group. Okay, so it is carboxylic acid. Monocarboxylic acids are there, dicarboxylic acids are there. So we will be seeing here what these amino acids are. Amino acids are the combination of amine plus acid. How are they obtained? They are derivatives of carboxylic acid. Carboxylic acid, suppose if you take a general formula or the carboxylic acid, if you take, this is acetic acid, one of the carboxylic acid, isn't it? Then, now when you take acetic acid has got a chemical formula CH3 C double bond O OH. Here one hydrogen is replaced by amine group. One hydrogen is replaced by amine group and you get amino acid. Amino acid. And if this hydrogen, again the second hydrogen is replaced by a R group, that R can be any alkyl or aryl groups, then you have a different amino acids. So the general structure of amino acid is NH2, CH, here R can be hydrogen, or any alkyl or aryl group, again C double bond O OH, C double bond O OH. So this is the basic derivative of the amino acids. Amino acids are derivatives of carboxylic acids in which hydrogen atom in the carbon chain is replaced by amino group. So that amino acids contain both amine group and the carboxylic group. Usually the amino acid term always refers to alpha amino acids. Usually always the term amino acid is always referring to the term. Whenever we say amino acid, we are always remembering the alpha amino acids. That means we know that there will be different types of amino acids. Okay, the IUPAC name of the amino acids are indicated by the position of the amino group. Where this amino group is present, whether it is present to the first carbon or it is present to the again second carbon or third carbon, depending on that IUPAC name which is suggested. Okay, now we will be seeing the second one is different classifications of amino acids. So anytime definition of amino acid is amino acids are derivatives of carboxylic acids in which the hydrogen atom in the carbon chain has been replaced by the amino group. Okay, now there is a classification. Second one is a classification of amino acids. Second important point what we are going to study is a classification of amino acids. Simply how they are derived, simply how they are divided in is, first one is alpha amino acid. They are classified first as alpha, beta and gamma amino acids. Now why it is called alpha, beta, gamma? Depending on the position of the amino group, depending on the position of the amino group, they are divided into three types. That is alpha amino acid and beta amino acid and gamma amino acid. Now what is this alpha amino acids? The first one is alpha amino acid. First one is, we will be seeing first one is alpha amino acid. Okay, if amino group is present, NH2 group, if it is on the alpha carbon, if it's on the alpha carbon, they are called alpha amino acid. Okay, NH2 group is present. Now, what is this alpha carbon and beta carbon? Let us see. I mentioned to you that there is a general formula of the amino acid, that is CH C double bond O OH. Here the third hydrogen is replaced by amine group. Then it is called amino acid. See, this is the functional group. Let me see. Acid has a functional group. So this C double bond OCH is the functional group having a formula C double bond OH. Acid has. Now the carbon which is attached to the functional group is known as the alpha carbon. Alpha carbon. So if the amino group is present directly linked to the alpha carbon, then it is called alpha amino acid. Alpha amino acid. For example of alpha amino acid is the basic amino acid, that is a glycine. Glycine. So glycine is an alpha amino acid, that is it has a chemical formula NH2 CH2 COOH. The amino group is present on the alpha carbon. Okay, again there is another one is alanine. Alanine also is an example, alanine, or some of you may can say alanine. Alanine also is an example of alpha amino acid. Here in this group that amino acid is present. See, that is alpha carbon, it is a beta carbon. Beta carbon is not having amino group. Here alpha carbon only is having the amino group. That's why it is called alpha amino acid. It is known as the 2 amino 2-amino propionic acid, because you see it is called 2-amino propionic acid because propionic acid. There are 3 carbon atoms. One carbon atom is called, we know that. How to name? One carbon is called methane. 2 carbons are known as the ethane. And 3 carbons, it is known as the propane. Isn't it? 4 carbons, butane. So, you know that. So, there are 3 carbon atoms. So, it is a propane. In that second carbon is having amino group. So, it is called 2-amino propionic acid. Another name is 2-amino propionic acid. Okay, so this is an example for alpha amino acid. Now we have another one is beta amino acids. Beta amino acids. Okay, now what are these beta amino acids? As we know that if amino group is present on the alpha carbon, it is known as the alpha amino acid. If amino group is present, if the NH2 group is present on the beta carbon, then they are known as the beta amino acid. Beta amino acid. Now, example for this beta carbon or beta amino acid is 3-amino propionic acid. 2-amino propionic acid, we know it. It is an alanine. How will we write C double bond O, OH? Okay, that is again hydrogen, alpha carbon no, again beta carbon. Okay, that is it can have 3 hydrogens. In this one hydrogen is replaced by amino group. So it is called beta amino acid. Beta amino acid. So this is here, it is a 3 carbon containing, so it is propane. It is a propionic acid, but it is second carbon. It is not having amino group. It is having on the 3rd carbon. So this is called 3-amino propionic acid. Okay, now third one is gamma amino acid. What is this gamma amino acid? If amino group is located on gamma carbon atom, if amino group is present on the gamma carbon atom, then it is called gamma amino acid. Okay, now what is main example for the gamma amino acid? 4-amino butonic acid. 4-amino butonic acid. Example is, see, you should know how to write chemical formulas. 4-amino butanoic acid. Butanoic acid. So name itself says butane. That means it is having 4 carbons. C double bond O, OH. First write the carbon atoms. 3, 4. 4-amino. That means the 4th carbon is having amino group. One is hydrogen. Another one is hydrogen. Again hydrogen. Hydrogen carbon valency is 4. So hydrogen, hydrogen. So what happened here? You can easily make out that this is alpha carbon, this is beta carbon, and this is gamma carbon. The carbon which is directly attached to the functional group is known as the alpha carbon. The second carbon is known as the beta carbon, and the third one is known as the gamma carbon. So these are known as the gamma amino acids, or their example for gamma amino acid is 4-amino butanoic acid. 4-amino butanoic acid. Actually, among these alpha amino acids are are the most important because they are the result of the product of hydrolysis of peptides and proteins. So among these, only alpha amino acids are very important. Among these, alpha amino acids are very important. How are they important? Because when the peptide bonds, hydrolysis of peptides, peptides means proteins. So hydrolysis of peptides, hydrolysis means addition of water. Addition of water on the peptides or proteins give alpha amino acid. Okay, now amino acids having more than one. This is the first classification. The first classification is depending on the position of the amino acid, the classification has been done. Next, second one is depending on the second classification is actually depending on the number of amino acids. Number of second classification is actually depending on the number of amino groups or acid groups that the classification is done. Okay, now what is this? The first classification in this is neutral amino acid. First classification is neutral amino acid. We know that acid is the acid group of COOH is acid, NH2 is amino group. It is a base. It is a base. So one acid group and one basic group is present in the amino acids. So what is this meaning of neutral amino acid? Neutral amino acid means equal number of both the amino groups and acidic groups. These acids will have equal number of amino groups and carboxylic groups. Okay, equal number. Equal number of amino group, that is basic. Amino group, we know that it is a basic group, and carboxylic acid, that is acidic group. Acid. Equal number of amino groups and acid group, then it is called neutral amino acids. We know that from the previous itself we can say that what all the things are example for the amino acid, neutral amino acid. We know here glycine is having only one acid group, one basic group. So it is an example. Here we know that here glycine is having one acid group, one basic group and one acidic group. So it can be an example for the neutral amino acid. Another one is again alanine. When you see it is also having again one basic group and one acidic group. So this is also an example for the neutral amino acid. Again another example is cysteine. Again another example is cysteine. Since you are not main students, I am not going in detail with these chemical structures which you find very difficult. So I will be giving you simple examples. So the first example for the neutral amino acid is glycine. And second example is alanine. I am not writing once more this chemical formula because I already explained to you. And second classification is, if it is one is a neutral means and another one is automatically either basic amino acids or acidic amino acid. So we will say the second classification will be basic amino acids. Basic amino acids. As the name itself implies that the number of basic groups or the number of amino groups are greater than the acidic group. These are amino acids containing more amino groups. These are the amino acid groups, amino acids containing more amino groups than carboxylic acids. The name itself implies basic. Here the basic group is amino group. Acid group is C double bond or OH. So basic amino acid, the term itself says that amino acids will be containing more amino groups than the acid groups. Example here is as a complementary students, please make sure that at least one or two examples for each classification you will be learning and keeping in your mind, because you are studying chemistry and we need that. So the first one, first example for the basic amino acid is lysine. Lysine. Okay, lysine has, actually it is alpha delta diamino caprioic acid. Okay, H2N CH2 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 CH, again one more basic group is there, NH2 COOH. It is a lysine. It is a lysine. So alpha carbon also contains one amino group. This is an alpha carbon, isn't it? Beta, gamma, okay, delta. You can write epsilon or any other symbol you can write. Epsilon. So alpha, epsilon, diamino, because there are two amino groups, so it is called diamino caproic acid. It is known as the caproic acid. And another example for the basic amino acid is, again you have arginine. Arginine is another example, or you can say arginine. Arginine is another example. Okay. And third classification is automatically it is acidic amino acids. It is acidic amino acids. As the name says, these are amino acids containing more carboxylic groups. More carboxylic groups than the amino group. Than the amino group. Okay, example for this. Okay, example is aspartic acid. Aspartic acid. Okay, aspartic acid chemical formula, simple chemical formulas only I am writing and teaching you. Tough because I know so complementary students you may find it a little difficulty to study and remember these chemical formulas. But at least one or two you should know. So example is aspartic acid. This another name is aminosuccinic acid. Aminosuccinic acid. And another example is, you can easily remember, that is glutamic acid. Glutamic acid. CH2, CH2, CH, NH twice, COOH. So it is called glutamic acid. Okay, so these are the main classification. First classification is depending upon the position of the amino group. Second classification is depending upon the number of amino groups and acidic groups. Again, there is another classification, that is classification depending upon their uses and applications. Okay, uses and applications. So depending on that, these amino acids are again classified as they are classified as essential and non-essential amino acids. Essential and non-essential amino acid is another classification. What is this essential and non-essential amino acids? Let us see. Essential amino acid, the first one is essential amino acid. The term itself says the amino acids whose absence in the body retards the growth and may even cause death. These are very essential. Without these, the human body cannot function. That's why they are called essential amino acids. And their body cannot synthesize these amino acids. And these amino acids you have to provide to the body through your diet. Okay, so what are essential amino acids? The amino acids whose absence. So amino acids whose absence can cause retard the growth of the human body. Growth of the human body. Okay. Why they are called essential? Because body cannot synthesize these amino acids. You have to give them through external diet or medicine, etc. That's why they are called essential amino acids. Another important point is they cannot be synthesized. They cannot be synthesized by body. You have to provide through diet. Provide through diet. Example are very, you know that you are since as botany students and home science students, most of you are always listening to this. Valine, phenylalanine, tryptophan, etc. are example for this essential amino acid. Okay, then what are non-essential amino acids? They are another classification. One is if essential means, another one is a non-essential amino acid. Non-essential amino acids. Okay, the amino acids which can be synthesized from other compounds by the body. That means they can be synthesized. They can be synthesized by the body. So you don't need to supply them through diet. You don't need to supply them through diet. That's why they are called non-essential amino acids. Okay, example for this non-essential amino acid is glycine, alanine and serine are called non-essential amino acids. Actually, all amino acids are essential for the normal tissues, growth and development. The term essential and non-essential is reserved for those which must be supplied through a diet. So, this is the basic introduction for your amino acids. Again, you have to study Zwitter ion, isoelectric point and structure, configuration of amino acids, etc. Okay, that we will be studying in the next class.